Good morning. Let us get started with chapter 3, which is on forecasting. Now, forecasting is a technique by which we can predict what is going to happen in the future. So, it can be forecasting of weather, it can be forecasting of demand, it can be forecasting population in area, and so on and so forth. From business perspective, it helps us understand what the demand would be so that we can plan accordingly, or what the population size would be so we can make things accordingly, so we can make the supply accordingly. So let us get started with this chapter 3 on forecasting. The definition of forecasting says that forecasting is a statement for future value of a variable of interest. Variable of interest is any aspect of business which helps us to take our decision. Like as we have discussed, like population or the demand, or maybe availability of raw material, availability of the right workforce. So those are variables of interest. So those are some aspects which you'd like to know beforehand so we can plan accordingly. There are two aspects of forecasting. One is the expected level of demand. Now, the expected level of demand can vary. It can vary by season, it can vary by period. For example, the demand for winter garments, they can be uh, higher in the winter and low during the summer. Similarly, demand for air conditioners can be high during the summer months compared to the winter months. So there is a fluctuation, and we know that that's going to happen, and that's called seasonality of the demand. The other aspect is the accuracy. How accurate is the forecast? Again, for every forecasting, there is an error, but we try to minimize the error as much as possible. Now, there are some of the common features for all forecasting. So those are to be there. Uh, some of them are the underlying causal system. Now, what is that underlying causal system? We assume some aspects remain constant, like the population. The population doesn't change, so we try to forecast the demand for the existing population. Next, forecasts are not perfect. We have discussed that before. Uh, forecasts for group of items are more accurate. If you put them together, it's more accurate. We'll talk about that more in other slides. And forecast accuracy for shorter time period is more accurate than for longer time period. Some of the elements of good forecasting is the forecast should be timely, it should be accurate. Now, the timely means if we take a long time to make our forecast, it doesn't make sense because it will not give us enough time to prepare ourselves. So it should be more as timely as possible. It should be accurate, it should be reliable, and it should be in a meaningful unit like pounds or maybe numbers. It should be in writing, like we want some specific information like how many. It should also be cost effective. We cannot spend tons of money in making that forecast. It should be reasonably priced so that we can get some value out of it. So what are the steps of forecasting? We should first understand what is the purpose of the forecast. In how will you use that forecasted data? That is important. What is the time horizon? For how long it should? Is it forecast for a year? Is it forecast for a month? Next, we should decide what is the forecasting technique. We should obtain a clean and analyze appropriate data. So garbage in is garbage out. Unless we have a good data, it doesn't make sense of making a forecasting model. And then we have to also monitor the forecast. What are the it's a cyclic process. We forecast, then we take our steps, and then again we forecast. It goes on, and there should be some monitoring. Forecast accuracy and control. All forecasts have got some error, but our objective is to minimize the error as possible. If we make forecast for a group of things, it is more accurate compared to forecast for a single item. Forecast for a longer duration is less accurate compared to forecast for a shorter duration. So keeping those in mind, we should understand what are the techniques we should be using for forecasting and how we are going to control the error which is going to occur in that forecasting. Forecast accuracy stands for, now if we try to take a look at this formula, it is error is actual minus forecast. What is actually going to happen and what we have already forecasted. Please remember this sequence: actual minus forecast. It is not forecast minus actual. So there will be problems which will require you to implement this formula. It is error is actual minus forecast. So if error is low, it is acceptable. If it is beyond certain bounds, it is not acceptable. So it can be an acceptable forecast, acceptable bounds, or it can be beyond that. So in that case, we have to make the forecast again. There are different techniques for measuring forecast accuracy. Some of the techniques are MAD, mean average deviation. Then is mean square error. The next would be MAPE, mean average percentage error. Okay, so using all these techniques, we can make forecast. MAD, what we do is actual minus forecast. We sum them up and divide it by n. So, and we also take the absolute value. Please don't forget this absolute value. Again, there will be some problems where we'll be using it. In the mean square error, we squared the error term. And in MAPE, we divide it by the actual and multiply by 100 to get the percentage. Now in this problem, just if we take the first row, we have the actual value as 107, the forecast as 110, the error, which is actual minus forecast, is -3. We take a modulus of that error, or absolute value of that error, which is 3. We get rid of that negative sign, we square it, and then we find the percentage. If we sum up the absolute value and then we'll average it, we'll get the MAD. For the square, we get the mean square error, and for the third column, we get the percentage error. Forecasting can be quantitative for qualitative forecasting and quantitative forecasting. For qualitative forecasting, we take into account the human factors, personal opinions, and hunches. Okay, so human factors, personal opinions, and hunches. For the quantitative forecasting, it is more data driven. So we try to make some statistical model to get into that, to make that quantitative forecast. So in this chapter, we'll concentrate more on quantitative forecasting. So let us look into some of the techniques for that quantitative forecasting. There are also some other techniques like judgmental forecasting, which includes executive opinion, sales force opinion, consumer survey, and Delphi technique. So each of these techniques, they are based on individual opinion, either the executives or the sales force or the consumers, or for in the Delphi technique, it is for the technique from, it is the opinion of experts, and in the Delphi technique it takes place in number of stage or sequence. Okay, so uh, again in this these are not data driven, these are more individual driven. Okay, but you should concentrate more on that Delphi technique and read more on how do you actually execute the Delphi method. Time series forecasting is another technique where on the x-axis we plot time, and in the y-axis it can be quantity demanded. Okay, so that is the basic understanding of this time series forecasting. So time series means the demand varies by time. Okay, so as the time increases, the demand will change, either increase, decrease, remain constant, whatever. Okay, the time series behavior can have some trend, it can have seasonality, it can have cycle, irregular behavior, and random variation. The trend is basically it has some increasing trend or decreasing trend. Again, please remember, time is plotted on the x-axis. Time is plotted on the x-axis. In seasonality, there can be seasonal variables. Maybe in the winter the demand is more, or in the summer the demand is low. This can be winter, this can be summer, and so on. The cycles are same as seasonality, but they are of irregular duration. The irregular variation is where there is a sudden increase or decrease. The random variation are where there are spikes. There can be a sudden increase in demand. So it is difficult to predict it, the random variations. Seasonality and trend. Seasonality, as I have discussed before, it can have an upward or downward movement. The population shift, changing income, that might cause this seasonality or this trend, upward trend or downward trend. In cyclic, it can be, there are cycles. It can be shorter cycle, it can be longer cycle. A bigger version of the cycle would be period, which is maybe for a year or for 2 years duration. So that is a cycle. So it is difficult to predict when there is a seasonality. We have to get rid of the seasonality. Then we have to forecast with that deseasonalized information. Cycles and variations. Now we have talked about seasonality, which are maybe for a month or few months. Cycles are for bigger duration. So if seasonality is for few months, cycles are for bigger duration, maybe an year or few years, maybe like the economy of United States, the way it varies in cycles. For random variation, there are some aspects of the forecast uh, which doesn't match with the actual happening. So that straight line, which is the one below, and that curved line, which is on the top, so there is some difference between those two, and that is the random variation which we cannot explain. The irregular variations happens all of a sudden without uh, much time for the forecasters to realize why it happened. Like a strike. So there was a production in a factory. All of a sudden there is a strike and the production drops. Okay, then maybe after some time it again resumes. Or maybe an weather event, like there is a demand which was increasing, but because of some weather shift, or maybe for an inclement weather on a particular day, the demand drops suddenly. Okay, so these are irregular variations. So we have to keep in track all these different type of variations. There are different types of forecasting. Now we are getting into the actual forecasting technique. One of that is knife forecasting. The knife forecasting is simple. Whatever happened in the last time period is your forecast for the next period. Say yesterday's demand was 10. The knife forecast will say the demand for today. Say yesterday's demand was 10, so knife forecast will say that forecast for today would be 10. Or it can be an addition of a particular value over last period's forecast. Like we assume that the forecast always increases by 5. So yesterday's demand plus 5, that would be knife forecast. So again, there are a number of examples in the book which you should look for this knife forecasting. For time series forecasting, it is based on the principles of averaging, and there are 3 different techniques for that averaging. One is exponential smoothing, then comes weighted moving average, and finally the exponential smoothing. So you should know all these 3 techniques for your exam: moving average, weighted moving average, and exponential technique. So these are, again, you should understand there is some error in all these methods, but they try to minimize the error as much as possible. So let's see what are some of these techniques and what are the errors which are associated with each of these techniques. Moving average. So this is the first technique for forecasting. We have already talked about knives, so knife doesn't really have much of technique. So in this moving average, what we do, the forecasting for time period T here, which is the subscript, is the average of past few periods. So AT minus I, that's what has happened, what has actually happened, say 1 period back, 2 period back, or 3 periods back. So we average those actuals, and that is the forecasting for time period T. So it can be a T minus 1, T minus 2, T minus 3. So we have A here, and we average it, and then try to forecast what will happen in the time period T. In this moving average, as we keep on getting new information, so we have two inputs. One is actual. AT stands for actual in time period t, and FT stands for forecast in time period t. As we get more actual information, it got to happen, so it cannot be done before. So once we keep on getting that actual information, the forecasting is done based on the current records. If there is fewer data, it is more responsive, that it changes frequently. We have more data, it is less responsive. Okay, and you can try it out, this averaging with a bigger amount of data and smaller amount of data. In this technique of weighted average, what we do, we assign some weightage to the actual record. Okay, and what is most important is the weightage assigned on newer records is more than the weightage assigned on older records. So W1 would be more than Wn. And the basic concept is current records will affect your demand more than what happened a few periods back, okay, or older record. So W1, so newer record, which is 81, is given more weightage than maybe 85, T minus 5, which is an older record. The next term is exponential smoothing. So the forecast for time period t is forecast for t minus 1, the previous forecast, plus, oh, actually this will be minus. Please make this correction. This sign would be minus here. So minus alpha t minus alpha at minus 1 ft minus 1. Now this term over here is the error term. Okay, and that is exponential smoothing. There are other forecasting methods like focus forecasting. Some companies use forecasts based on current performance basis. Apply several forecasting method of the last several periods of historic data. The method with the highest accuracy is used to make the forecast. And so we basically try out with the different methods, and whichever gives more accurate information, we try to implement that technique. And the process is repeated every month. That is, we try different techniques and see which one suits us most or suits the business organization most. Then you have the diffusion model. What is the diffusion model? Historic data on which is best forecast are not available for new products. So a company is launching a new product, but you don't have any information on that. So what you do, you try to build your model, your forecasting model, using information from other similar product, okay, which is already there in the market. And based on that, you can make your forecast. Again, for new product, information is not available because it was not there in the market. So you have to do that based on similar product. It is done on market potential, on word of mouth, or mass media. So those are to be taken into account while doing this diffusion method forecasting, because you don't have actual information on that product. trend, as we have discussed before, like the demand has got a rising trend. It rises linearly. So this is a linear trend, so because it's a straight line. Or it can be a non-linear trend. It has some curves on it. Okay, that's a non-linear trend. So linear trends are easier for us to calculate because it follows a straight pattern. Non-linear trends, because if you see over here that they have a the maximum point and a minimum point within a particular time frame, so it's difficult to predict this non-linear trend. And at exactly what point you want to predict, that depends very much on at which part of the curve that time frame is. So over here it is high. Again, within a certain time frame, after a certain time frame, it again decreases. But again, if you cross this point, the lowest point, again it starts rising. So it's difficult to predict these trends. Linear trend, it is like an equation of a straight line. Y equal to y is equal to mx plus, say, b, which is an y-intercept. Okay, so you can depict, you can change this b by c or whatever, but this stands for the y-intercept. The m is the slope of the line, and this is the independent variable. This x is the independent variable and y is the dependent variable. So this is the equation of the line, which you must have learned in your maybe high school days. And using this simple equation, you can predict the demand based on some independent variable. For this case, the independent variable might be time. Now, trend adjusted exponential smoothing. What happens in this model is there is the trend along with a forecasted value. So this is the previous forecast plus smoothened error, okay, that ST, and with that you add this trend, capital T subscript small t. We have to add that because, say, as I said, that if it's an increasing trend between two time frames, there is a increase in demand just because of the trend. Okay. Now for seasonality, what do? We sometimes add it with the forecast or we multiply it. What is that? Say you forecast the demand would be 50, but because it's winter and in the winter the demand for winter garments would be more, we add a seasonal trend of 10, additional 10. Or we can also multiply, we multiply 50 by 1.2, so that additional 0.2 is the seasonal factor. So we can either add or we can multiply with the seasonality to get the adjustment for seasonality. So when we have to make a forecast for seasonality, so there is a seasonality in the information, but we cannot forecast with that seasonality. What we have to do, we have to get rid of the seasonality so that it becomes a straight line. That is called de-seasonalizing the data. You have to get rid of the seasonality. Then we forecast. This dotted line is the forecast. Okay. And after that, we again have to incorporate seasonality to get the actual demand. So we first deseasonalize it to run the mathematical model, then we incorporate seasonality to get the actual, uh, get close to the actual demand or actual data. For cycles, as we have said before, cycles are for longer duration. It is very similar to seasonality, but it can be for a year, it can be for a few years. Again, like seasonality, we can get rid of the cyclic information, then make the forecast, and again we can incorporate it. We are getting rid of that, of the cyclic information, so that we can get a straight line. Once we get a straight line, it helps us build our mathematical model. Okay, so we talked about seasonality, we talked about cycles, but I can say that in the exam we usually don't give any problem on seasonality, on cycles. We give it on those three techniques of averaging, which we have discussed, and also the naive forecasting. Associated forecasting technique, the home value can be a factor of home and property size and the location and so on. So the associative forecasting says that, say, demand, it depends on number of factors, associated factor. Okay, say the price, the population, the size of the home and so on. So we try to take those associative factors, which we also called mathematically independent factors, so that we can make a better forecast. So those are associative techniques which are required for forecasting. Now, this technique of using associative factors is called regression technique. In regression, what we do, we say y equal to, say, gamma 1 plus gamma 2 x. Now don't get confused with this term gamma. I could have used a or b or whatever. It's just a coefficient, and this x is a independent variable. So in the regression, the basic concept says that y varies on y, which is a dependent variable. It depends on some independent variable. So this is dependent, this is dependent variable, and this x here is independent variable. So this x influences this y. Okay. Linear simple regression assumptions. There are some assumptions in this regression as well. Like in forecasting, there is some assumption. In regression, there is some assumptions. There are some assumptions. So variation along the there are some variations which should be random. By random variation, we mean if we take a regression line, the actual can be higher or lower. So it should be random. So it should not be only higher or not lower, the actual. The deviation around the average value should be normally distributed. The predictions are made only within the range of observed value. Okay, so it should be for a particular period of time. That's when the regression can be done. It cannot be done beyond. It cannot be done for next 20 years. It has to be done within a time frame. Now, in the regression technique, we have to consider certain issues. The first would be the concept of linearity. We plot independent variable on the x-axis and dependent variable on the y-axis. We assume that the dependent variable varies linearly with the independent variable. Okay. The next point is there can be number of independent variables x1, x2, x3, which can stand for maybe the price of goods, the population level, or maybe the demand of complementary items and so on. All those different variables influences the demand y, which is plotted on the y-axis. Now forecasting can be of reactive nature or it can be proactive. In the reactive, what we do, we try to match the supply with the forecasted demand. Okay. In the proactive, what we do, we try to change the demand, maybe increase the demand using advertising technique or pricing strategies or product modification. So proactive is getting more involved with the demand and changing it. So in brief, we have covered most of the techniques which are used for forecasting in the business. I'd request you to go through some of the problems which are discussed in the text so you can get yourself more familiar with some of these techniques. Thank you.